Alright, whether this AIME likes it or not, we're gonna finish it real good, okay? Once we finish AIME, we're gonna move on to other Olympiads. It'll be so exciting. Let's go. Right now, I have requests for more Yusuko, more Yusubo. So, we're first gonna do Yusubo, and then hopefully I'll blend in some Yusuko there too. But for now, we gotta finish this AIME. So, problem 14. Hello everybody, I'm Kar, and today we are gonna be working on the AIME that we started last time. Let us get started. Centered at each lattice point in the coordinate plane is our circle of radius 1/10 and the squares of side length 1/5, whose sides are parallel to the coordinate axis. The line segment from 0, 0 to 1001, 429 intersects m of the squares and n of the circle. Find m plus n. Okay, so I guess we could just do this separately. Let's do the squares first, because that seems fun. So it's 0, 0 to 1001, let's say, and 429. Very cool. And then the squares are just at every lattice point you got like a 1/5 side length. Okay, so it's like the squares are like this, and then the circles are just like that, like inside the square, tangent to the square. So every circle that's intersected, it'll intersect one of the squares, but the other way is not true. So you basically have like some lattice points where it intersects both the circle and the square, and then it has some lattice points where it only intersects the square. So in that case, it might be better to actually just do circles first, and then find out how many squares only. So basically, what's the slope of this line? It's 429 over 1001. Is that simplifiable at all? Well, the top one is divisible by 3. Let us prime factorize this boy. 3 times 11 times 13 seems legit. And then, what is 1001 divisible by? Oh, 11. So we'll divide that boy out. So 99, 11, 1. So 91. So our thing should be 39 over 91. Okay. So this is like a little bit more than 1/3, so let's just pretend it's actually, So it should be like between 1/3 and 1/2. So if we draw out like a 3 by 3 grid, let's see how it looks. So we go from here, and 1/2 would make it like go there, and 1/3 would make it go there. So it's probably like somewhere around there. Okay, so it for sure intersects both the circle and square of this guy. And then this guy has to be 1/5 away at some point. Well, let's see. So when it goes 4/5 over, right? It goes 4/5 over, and then it goes times 39 over 91 up. Now this is clearly bigger than 1/5, so it's not going to touch this square at all. So this guy doesn't have to worry about anything. But then at 2, it's probably in range of this guy, right? There's got to be a smart way to do this, though. So what's m plus n? That's going to be like the number, 2 times the number of lattice points where it's within 1/5 of it. Or it could basically 2n times the number of circles, plus, or wait, what? 2n, whoops. 2n plus the number of squares where it doesn't intersect the circle. Why don't we rotated the axes now? So what is the farthest away from this line that the square gets? It's probably this tip point. So, this slope over here is going to be, okay, let us draw this way bigger. Let's get rid of all this nonsense. Okay, so let's first think about circles, right? So you got this, and you got this, and basically, this, let's just say that this is a line with slope 39 over 91. Then this distance over here is 1/5. But then a square is going to be like that. And the farthest away it gets from this line is going to be, we'll have to calculate this out. Is there a fast way to calculate this out? Well, anyway, so basically we get rid of this. So this would be 1/10, right? So then by using the slope, we know that this is 91 over 390. Yeah. So then if we use similar triangles, we know, what do we know? Do we know anything? I don't think we know anything. So this is 1/10. So the sum should be 91 plus 39 is 130. So this overall hypotenuse should be 130 over 390, which is 1/3. Okay, so if this is 1/3, what's the hypotenuse of this one? Real quick. Is there a 3991 triangle? Is that a thing? Do I really have to square this nonsense? I feel like it would be an actual triangle. Oh no, it can't be. So that's not an actual nice number. Well, okay, let's just pretend that we knew this length. Will that help us at all, though? Well, then we know that it's like, it has to intersect, it has to pass within a certain distance of the points. This is an interesting problem. Okay, so why don't we just do it in order, right? So, this is x equals 0, it's guaranteed to intersect this. Okay, let's think about it this way. Let's see, like every x coordinate it goes through, how many squares could it possibly... Let's just think about y coordinates. So, this is 1 apart, this is here, this is there. So right here, this is 3/5 in between them. And then this over here is, oh sorry, 3/10. What? No. So this is 1/10, this is 1/10. So this here is 4/5 basically. And then this over here is 2/5. Oh, this is not to scale at all. But anyways, basically what this says is that at maximum, it can only intersect one square per, like x coordinate. And that's the same thing for circles. That maximum intersects one circle per x coordinate. But what about horizontally? So this is 4/5 instead, and then this is 1/5. Whoops, 1/5. So could it hit both? If it hits here, could it hit the other one? Yeah, guaranteed will hit the other one. But it's possible that it only hits one, right? So 2 minus 2/10 would be 8/5, or 9/5. Whoops. So it can't hit 3, but it could hit 2 or 1 going vertically. Could it hit 0? No, it can't hit 0. So basically, so let's say that like A is the number of 2 square hits going vertically, and then B is number of 1 square hits. So basically, then we basically have that 2A plus B is equal to M, right? And then A plus B is equal to the number of lines that we have to hit. So we go from 0 to 429 vertically, right? So that means that there's 430 squares. Okay, and then similarly going horizontally, we could either hit 0 or 1. So it would be, what would it be? It would be, well, let's say that like x is equal to 0 hits and y is 1 hit. Then we know that y is equal to m, and then x plus y is equal to the number of x lines that we had to cross, which is going to be 1002. So basically that means that x is equal to 1002 minus m, but I don't know how helpful that is. Well, what does that say? Then we basically get that a is equal to m minus 430. Then means if we combine the two, that x is equal to 568. No, sorry, 572 minus a. Does that help at all? I feel like this is the way to do it. It should be. I need a better diagram. Let's see. Maybe if we can draw this better, it would make more sense. Let's see. So each of these squares are like tiny, so we should do that. Okay. Oh, maybe we could like set like certain y coordinates, like certain fractions where it has to hit in order for it to hit one of the things. So, like let's say that we have our square. Wait, hold up. So let's say that we have our 2 points here and here, and we have a square here and a square there. If it hits here, then it's guaranteed to hit 1. If it hits anywhere from here to here, then it hits 0, and if it hits here, then it's going to hit another one. So what is this right here? What is this height? So this over here is going to be 1/10. So this over here is going to be 39 over 9/10. And then this is 1/10 as well. So if we add these two, then you get 1/3. So this right here is 1/3, this length over here. So basically, we start with 0, then we go to 39 over 10, or 39 over 91, then 78 over 91. Because our line is y is equal to 2x. Our line is equal to 39 over 91x. So for x equals 0, that's 0, then 39 over 91 for x equals 1, and then 78 over 91 for x equals 2. And basically, as long as this is between 1/3 and 2/3, it'll be 0, and if it's not, then it will not be between 0. Wait, what? Wait, maybe I should do it vertically? Yeah, if I do it vertically, then there's less things to deal with. There's only 39 options to deal with. Yeah, let's do that. Okay, so this right here is going to be 1/3, or sorry, how does this work now? So now it's different because if it hits here, or sorry, there's a certain point at which it will hit 2. Wait, could it hit 0 though, this way? Because it could be right here and then just thread the needle right there. Yeah, it could. So this right here is 4/5, and then this right here is 1/5. Yeah, so it could hit 0 theoretically, or it could hit 1. Could it hit 2? Wait, it can't even hit 2. Wait, is that what I already said? Hold up. Oh, so I was just trolling. So even if you went from the lowest one to the highest one, it still can't hit 2. So this would still be b is equal to m, and then a plus b equals 430, and then a is equal to 430 minus m, and then this would be plus a. Okay, well, I mean, that didn't help too much, but we basically know that it'll hit 0 if it's like between this point, which is 1/10 times 91 over 390, okay, and then this point, which is another 91 over 390, and if we add these, we once again Oh, if we add these, then we get, oh, this is where we actually get 1/3. The other time it was not right. Wait, what? Oh, yeah, the other time it would not be 1/3, but now it's 1/3, so this should be 1/3 over here. Okay, so it has to be within 1/3, and we know that our line is also 91/39y. Yeah, as long as the fractional part is between 1/3 and 2/3, then it will hit 0. So we want to find out what x is, and then we can find what m is. Oh, there's so many x's and y's, but anyway, this should work. Okay, so it starts off as 78. What's it? 91 mod 39. So the initial fractional part is 12, right? Or no, 13/39. Wait, what? Wait, I'm small brain. This whole time we hadn't simplified the fraction, bruh. God dang, how did I not oh my, I'm triggered. Bruh. So it would be 7/3. God dang. So the initial fractional part is 1/3, then 2/3. Wait, seriously? Hold up. So 91 times 11. What the heck? Bruh. Why am I so small brain? God dang. So it first goes 1/3, then it goes 2/3, then it goes 0, then it goes 1/3, then it goes 2/3, then it goes 0. So basically, does intersecting the squares, okay, so it always intersects one square then, because it just hits the edge of the square. Bruh, I'm actually so small brain. But it's okay, don't worry, we got this. Bruh. 7/3, oh my god, how did I not, oh yeah. So m should just equal to 1002, no, sorry, m should just equal 430, okay. So now we just have to find circles. Circles is slightly more complicated, because then you have this and you want this, okay. So this is 1/10, which means it never intersects a circle, right? Or it only intersects a circle when it's 0. So 1/3 of the time it intersects a circle. Or sorry. So it's like 0, 1/3, 2/3, 0, 1/3, 2/3, 0, all the way up till 429. So there's 143 zeros plus 1, 143, so 144 circles. So we had to count the number of circles, right? It starts at the very center, which is obviously intersecting the circle, then it goes to 1/3 and 2/3, which clearly don't intersect the circles, because it's barely even touching the squares, right? So it doesn't touch the circles. So we had to find the number of zeros, and we know that it ends on a 0 too. So then it'll be like this, and we know that 429/3 is 143, but then there's an extra O at the end, so it's 144. So in order to find m plus n, we do 430 plus 144, and we should get 574. If that's the answer, please be the answer. Let's go! Yes! Let's go! Wait, what? How did I get a different question mark? Wait, hold up. Okay, I see. They just did it a different way. But yes, let's go. We did it. Let's go. Very nice. Epic stuff, guys. Epic stuff. Oh, they did my original strategy, right? You do 2 times the number of circles plus the number of squares that don't have the circle intersect. Okay, very cool. Okay, that was actually honestly a pretty fun problem. Dang, okay. That took me quite a while to get, but at the end we got it, and that's what mattered. You saw how excited I was. Come on. But anyways, thank you guys for watching so much. As always, if you enjoyed the video, leave a like and subscribe for more. Let me know what kind of things you guys want in the future. Coming up, Yusuko, don't worry about it. Alright, thank you guys for watching again, and see you guys next time!